Hi, my name's Chef Kotz. I'm going to talk to you today about what to do the first time you encounter data. Beverage up because this is going to be a good one. The conversation I want to have is really with the students from my Finance and Math 217 courses because it corresponds with a particular document that I put together to sort of lay out the way people should clean a data set when they first encounter it, and then how they can use descriptive statistics to get a high-level overview. In just a second, I'm going to demonstrate this to you on an Excel document, which I've generated from the pretzel factory that I run, which contains lots and lots of data. There's 4 different types of pretzels. I got a bunch of different managers. This data is collected over the course of an entire year. There's money involved. It's a big data set. But the point of statistics, one of the points of statistics, is being able to condense lots and lots of bits of information, thousands different little bits of information, and being able to summarize it and give a condensed understanding of what it is that we have as a whole. So we take lots of information, condense it down into things like central tendency and dispersion, so we can get a basic understand of where the middle is and what the data is shaped like. And once we go from there, then we can delve in a little bit more into detail if we need to. But generally speaking, if you want to take a look at an entire year, you don't want to have to go through each day by day. You would much rather be able to say divide it up by month if necessary, or look at a couple of different managers and summarize the way that stuff works. In order to do that, I'm going to show you 2 documents. One is the data set from my pretzel factory, and that is here. As you can see, there's a number of different elements in this data set. For example, I have a number of different employees who serve as managers, and each one of these rows represents a record. But I'm going to get into what each one of those things represents in just a moment. The data that's in this data set, there's employees, there's the date, there's the month of the year, there's the day of the particular week, how many traditional units, so traditional pretzels were sold, how much money I made on traditional pretzels that day. Odd rods is another type of pretzel and how many dollars I made selling those. There's the Kotz knots, and there's also buns and noses, which is a specialty product. Like Guns N' Roses, but anyway, this is the data set, and we can take a look at how many days we have. I said that it was going to be 365 days. We come to the bottom down here, and it goes all the way to December 31st. So that's lots and lots and lots of data. Given all that data, we should have a strategy that we can use for any data set that's either like this one or, I don't know, some other data set that you might encounter. Or if you need to think about structuring a data set of your own, you should be able to think about it in a way that's going to yield the quickest and easiest and best types of summaries. So in order to do that, I generated this particular document. Not that one, because we just looked at that, but this one. It's a little Word document. Now, both of these documents are in the first module for my first module in Sakai for my Finance and Math 217 courses. But this document describes how you should look at and think about data in order to get it into a way that allows you to easily summarize it. Enough preamble, I'm going to dive in. First thing you need to do when you get to data is clean the data. And there's a number of different things that could be dirty about data, but in terms of simply its shape and its structure, we need to think about each row being a record. So in the case of this particular data, each row represents a record, because this record is for January 1st, January 2nd, January 3rd, and so on. Each row represents a record. Each column represents a variable, sometimes called a field. In this case, this field is employee. This is date, month, day, traditional units, and traditional sales. Notice that each column has a header with a different name. And it's important that each of those headers has a different name. You're going to find out why when we get, a little bit down the line here. I'll tell you it has to do with pivot tables and pivot charts. But the header should be the name of the variable. In this case, this is the employee column, and row 1 serves as the header. This is the employee column, the date column, the month column, and so on. It's all right to start with row 2 as being your data, as long as row 1 is your header row. Lastly, you need to make sure there are no blank rows. No blank rows is important to Excel because Excel has a little bit of intuition about the way data is structured. If I hold the control key, this is a little keyboard nonsense. I'm gonna hold the control key. There's my marquee. I'm not holding the control key. I was lying. I'm not holding the control key. See, arrow just moves it around. If your screen is moving, but your marquee is not, odds are you need to press the scroll lock button. The scroll lock button is a button that toggles whether or not your marquee moves around or your whole screen scrolls around. You want it in a way that it's just the marquee moving. Now I'm going to hold control. Now control does a thing where it allows my marquee to jump. I hold control and hit down. I'm going to hold control and hit right. As you can see here in column L, this is the last column of data. Column M has no data. The reason when I hold control and hit down or up, it will go, the marquee, that green rectangle, will go to the end of the data. In some cases, control left, it will go to where it can't go anymore, the first column or the first row. But if I now hold control and hit down, it goes to the last record or the last row, because everything below 366, well, there's nothing left. If there was something here, and let's say row 368, I'll go all the way back to the top. If I hold control and hit down now, it stops where the data stops. Blank rows, such as 367, separate data sets within a particular worksheet. That separation we can't have. Excel needs to know that all of this data is put together. Let's get rid of that. No blank rows. So those are the first big key things when it comes to just setting up a data set. Make sure each row is a record, each column is a field, and that there is a header row for each of those fields. We want no blank rows, and that's it. Once we've got our data cleaned up like that, we can start thinking about how to, and here's where I'm going to start applying some of the conceptual stuff like central tendency and whatnot. We can think about summarizing the data. Now, my students are kind of maybe tired, maybe not, hearing me use the alliteration or root words or anything like that. For example, summary, summarize. I've got a whole bunch of things, and if I want to summarize it, there might be some function, something in Excel that somehow tells me something I might be caring about. The sum. A summary could be a sum. So if I wanted to summarize the total number of things that I've sold, I'm going to want to use the sum function. Eventually, I'm going to want to maybe find out what an average day is like. But first and foremost, how many pretzels did I sell over the course of the year? I'm going to use the sum function to summarize that. There's a whole series of other functions or formulas that we can use. Formulas may or may not contain functions, but they could contain mathematical operators, plus, minus, multiplication, division, and so on. But this is really about having a good look at what descriptive statistics are important for summarizing data. I'm going to hop back to that now. So the second step, and there's 3 steps here. First, it's clean. Second, describe. Third is chart. The second step is to describe the data with descriptive statistics. Anytime you take a sample of something, you can describe what you see. Populations are generally impossible to observe the entirety of. So you take a sample of it and you try to make an inference about the population from the sample. But let's describe what we have here. Two important things that we always start with when it comes to describing data: central tendency and dispersion. Central tendency is mean, median, and mode. Qualitative data can only have a mode, but quantitative data can have all three. In this case, the manager or employee, employee, manager, employee, if you're the only employee working, then you're kind of managing the joint, is qualitative. It's nominal level data. It's just a name. I cannot take the median and I cannot take the mean of these particular names. But if I was able to count how many days Brutus worked, how many days Jasper worked, how many days Elvis worked, I could come up with a mode, and that's the person who worked the most days. Unfortunately, if I just use the mode function in Excel, well, it doesn't like if I do that. Now, there are some workarounds for this. For example, I can count if for this particular array, whether or not Elvis was the manager on this particular day. And I see that Elvis was the manager on, well, that's the function you need to use in order to find out how many days Elvis was working. 168 days. Now I would have to do that for Jasper and for Brutus. And, well, that could be not a big deal if you only have 3 managers, but if you have lots of different people, that could be a big challenge. Let's hope that there's an easier way that we can take care of that question. So for qualitative data, the only thing you can calculate is a mode. On the other hand, quantitative data can have all 3. Quantitative data would be something like, in this case, the number of units sold. Now, I keep having a problem when I get to the bottom of the sheet that I can't see my headers anymore. So I'm going to show you real quick how we can freeze this header row right up here. I'm going to click on this second row. And up here under the view part of the ribbon tab, I now have this ribbon for view, and I can freeze panes. I'm going to freeze the top row. Now that I have frozen the top row, I can scroll down and let it go. Pop culture reference of a movie I haven't seen, don't care. Anyway, top row frozen. Now it doesn't go anywhere. But now it has not gone anywhere, I can talk more about the mean, the median, and the mode when it comes to quantitative data. The mean, if I want to calculate the mean in Excel, unfortunately, Excel doesn't understand the word mean, although some might think it does, waka waka, but I have to use the average function if I want to find out what the average day looks like. On the average day, from E2 to E366, the average day is somewhere around 2,000 pretzels, in this case, 1,995. I might also want to know, what is the median? Well, that function is actually median, 1,990. So it looks like the mean and the median are pretty similar. Now, there's one challenge I have here when it comes to calculating the mode. Specifically, as far as Excel is concerned, when it looks for the mode, it's going to look for one number, which occurs most frequently. But as far as I'm concerned, 1,995 and 1,990 are pretty much the same number, plus or minus 5. And when we're talking about the order of, on average, 2,000 pretzels every day, 5 here is less than 1%. It's dust. That could get dropped on the floor. That could get fed to a dog. It's not all that different. So if I tell Excel to, strictly speaking, calculate the mode, I'm not really doing myself any favors here. The mode could be 2,112. The mode could be 6. But that's only because of those 365 days, there weren't any days which had the same number of pretzels, the exact same number of pretzels purchased. In that case, the mode doesn't really tell me a whole lot. It just so happens that there were 2 days in which exactly 2,119 pretzels were sold. How we get around this is eventually we're going to chart this data. We're going to look at a histogram, and we're going to provide ourselves some interval ranges where we say, oh, anything from 1900 to 2100, that's about the same. Or maybe a more narrow range, anything from 1950 to 2050, 1975 to 2025. Hey, we can decide the size of the interval. That's the more important part of the mode. Not if there's a single number which occurs most frequently, but rather, is there a range in which we can bucket a bunch of things together? Strictly speaking, using Excel as we have it set up right now, I can say, all right, give me the mode of this data. It's going to tell me 1982. There's a couple of different mode functions that we might want to use here. But because I rarely, if ever, actually use this mode function, I don't bother with it. I'm more concerned about intervals than single modes. Mean, median, mode, that's central tendency. The next thing we look at after central tendency is dispersion. Now, the types of things that we use to describe dispersion are range, standard deviation, and variance. Standard deviation is the square root of the variance. They're exactly connected like that. However, we sometimes find ourselves in the statistical world talking about variance and using standard deviation. First, you have to come to terms with the fact that those are both things that describe dispersion. But variance shares a root with words like vary, V-A-R-Y, or variable, or variety. Anytime we're talking about variance, generically speaking, we're talking about how much variety there is in a data set. If a data set had 0 variance, that means 0 variety, and everything is exactly the same. The higher the value for the variance, the higher or the more variety there is. We could say the same thing with standard deviation, but standard deviation has 5 syllables where variance only has 3 and it's 1 word. I think it's just a colloquialism. Standard deviation, though, is what tends to be more useful. And we're going to use standard deviation when we talk about the dispersion here. But if I wanted to, I could calculate all 3. And I'm going to calculate all 3. Also, unless you're told you have population data, you're likely going to use the sample standard deviation formula. It's there's a difference, a functional difference I'll show you here in a second. But those 4 things, we might think about the range, the variance, the standard deviation. But we're going to be working with variance of potentially the sample, standard deviation of sample. Or maybe we need to do the variance of, let's change this from sample to population. That's a place on another screen. So we might, and let's get some different justifies here. Okay. If I want to take the variance of this particular sample, I start telling Excel just the way I had to tell it average or median or mode. I want to say I want variance. And I type VAR, and it turns out there's a number of different functions here. But one is .p and one is .s. As it turns out, .s is sample variance. Sample variance here, and that's a value for sample variance. If we do the same thing for standard deviation .s, I could do the same thing for population. Variance.p gives me the population variance, and then the variance for, or sorry, the standard deviation for the population looks like that. actual difference between, if we just look at the standard deviation and the standard deviation for the population, the actual difference between those two numbers is very small. 0.13. 0.13 relative to 100, 0.28 is less than 1%. It's practically 1/10%. It's dust. When you have a large enough sample, the difference between your standard deviation using the sample formula and the standard deviation using the population formula is negligible. But generally speaking, you're going to be operating within the confines of the sample. So use sample. Use those. Those are the ones we tend to use. If we do use something else, it will be specific and intentional. In order to calculate the range, I might want to take the maximum. Actually, I do. There's no might about this. Minus the minimum. And let Excel correct my lack of parentheses. The range here, 576. We get there by taking the maximum minus the minimum. So there's a range of 576. Once we have all of this stuff the way we want it, so we've got mean, median, mode, range, variance, standard deviation, variance, standard deviation. I'm actually going to delete these two because I don't need those. Bye-bye. I'll come back and take a look at here. So now we can do dispersion, range, standard deviation, and variance. Generally speaking, use the standard deviation formula. The other things that we want to think about when we're describing the data beyond central tendency and dispersion might be the skew of the data. In this case, if I want to calculate the skew of the data, I'm going to say skew. Listen, Excel is not trying to come up with special terms for things that we already know. It's trying to be as intuitive as it can possibly be, except in the case of the mean or the average. Average isn't that not intuitive. So here's the formula for the skew. Again, in all these cases, I'm taking E2 to E366 for this particular column. It's the traditional units, the number of traditional pretzels sold. In this case, the skew, which is a number that can range from -3 to +3, is practically 0, which means there's almost no skew to this data. It's likely symmetrical. We can also think about the rest of this stuff here, which is in D&E. Discrete variables are counted, but continuous variables are measured. As we can see here for units, there are no decimals. So we are only selling whole pretzels. We are not selling parts of pretzels. We sell entire pretzels and only entire pretzels. That's discrete data. On the other hand, in this case, we can talk about the amount of money we have made here, and we can have decimals. We can have dollars and cents. An easy colloquialism to, or I don't know, whatever. An easy way to remember this: discrete variables are counted. You would say the number of blank. Continuous variables, you would say the amount of blank. So we come back here and we say the number of pretzels or the amount of pretzels. The amount could work, but ultimately the number of pretzels sounds better. It's discrete data. For traditional, well, is it the number of monies or the amount of monies? Well, don't say monies. You would say the number of money or the amount of money, and well, I would say the amount of money. The number of pretzels, the amount of money. That one is discrete. That one is continuous. All of those things, as I demonstrated down here, we're done with formula. Once I have these formula written the correct way, I can copy and paste them. And now we can see that the average or the mean amount of money I made on traditional pretzels was on the order of $6,000. The median was pretty close to $6,000. There's a much wider range when it comes to the amount of money I made on traditional pretzels. There's our variance, there's our standard deviation, and it looks like the skew for all of them is right around 0, except maybe that one's a little higher. In this case, I was able to calculate those descriptive statistics by first writing formulas for all of these and then copying for each one of the fields going across the columns. The other way I can do it is with the pivot table. That could be easier. And in fact, it is easier to do a lot of the different things that we're going to talk about. However, in some cases, you may need to use the formulas because you want to calculate something, for example, standard error. Standard error is depends on the central tendency you're using, if it's mean or if it's proportion. But you may want to think about the standard deviation divided by the square root of the sample size. And that's how you calculate standard error. I didn't say how you calculated sample size, but sample size, otherwise known as count, I used something similar before. I would say count. How many things are here? 365. 365 days in a year. But if I wanted to calculate the standard error, I would need to take the standard deviation and divide it by the square root of the sample size. So now I have a standard error associated with the sales of traditional units. Later on in the modules, we'll talk about exactly how we use standard error. Standard error is useful for comparison. So if this is my mean, I can compare other means of a particular size using the standard error. But that's something that we can't do in a pivot table, which is it's really useful. Standard error is probably my favorite statistic. It's really, really useful, but you can't calculate it in a pivot table. Let me show you how to generate a pivot table, because pivot tables can be used to generate contingency tables or crosstabs. Remember, no blank rows when you're cleaning data. Having left a blank row here in row 367, I can tell Excel that this stuff down here is summary information. But this stuff up here is still the data set. So with my marquee anywhere in the data set, there's a number of different ways you can do this. I have it on my quick access toolbar, but if you click on the insert for the ribbon tab, you can get the pivot table on the ribbon. I say insert pivot table, and look at that. Excel knows that I'm referring to cells A1 to L366. L366 is the bottom right corner of the data set. A1 is the top left corner. When I insert this pivot table, by default, it's going to put the pivot table into a new worksheet, which is where I want it, and it's going to use the data source that it recognized here. You will get an error if you have any of those unclean things that I referred to at the top, such as an entirely blank row, fields that has the same name for a couple of different columns. And now we've got a pivot table. Pivot tables are really useful for summarization. I'm going to show you how we can do a lot of that summarization that we just did with the formulas, but we're going to be able to do it efficiently for a number of different variables. And then the next thing that follows is showing how we can use a cool tool called PivotChart. PivotChart generates a pivot table, but at the same time, it generates the chart associated with that table. One of the big challenges with charting in Excel can be, how do I generate a table in a way that will give me a picture that I really want? Now, in this complex data, maybe I want to think about, managers working on certain days and whether or not weekend days generate more sales, or if a particular manager sells more pretzels on a particular day of the week. Already, I'm incorporating lots of different variables or fields. The manager, the day of the week, the type of pretzel. There's lots of different things. That's 3 variables, length, width, height. Now we've got a 3-dimensional complex problem. How do you put 3 dimensions on a thing that's only got columns and rows? That's complicated. Pivot charts are a great way to summarize that. One problem. It's January of 2016, and to the best of my knowledge, Excel for Mac doesn't have pivot charts. You can try Googling that yourself, but I think that's the case. So that sucks. I'm sorry that you don't have that functionality if you're using a Mac. There are rumors that in the future, but I'm not here to talk about rumors. I'm here to show you how to do pivot tables and pivot charts. Now that I have a pivot table here, I have a number of different fields. Remember, I said that these fields all need to have unique names. And hey, these are all the same names that I had before. Now on this sheet 3, which is actually our data sheet, and sheet 1, which is our pivot table, now that I've got the same fields that I had across the top here, I can start using them to generate a summarization over here. So one of the things I wanted to know was which employee works the most days. So this field employee, I drag into rows. Now each row represents an employee. And as you can see, I've got Brutus, I've got Elvis, and I've got Jasper. I've got 3 employees, but I don't have any numbers next to them. Anytime you want Excel to put a number into your table, you've got to put it down here where it says big sigma values, because it wants to summarize the values. Big sigma means sum. In this case, they're not necessarily talking about adding up all the things. It could be adding up. For example, if you drag, hey, there's sum, drag it out in the ether and it's gone. Let's drag a sales down here, say sum, drag it out in the ether, it's gone. Day, say sum. Wait a minute, that says count of day. Why, when I drag down this, for example, odd rods sales, it says sum, drag it out in the ether and it's gone. But if I were to take something like month down here, it says count. The reason? If you have something like, a quantity, Excel is going to default to sum. However, since you cannot add Sunday plus Monday plus Tuesday plus Wednesday plus Thursday, that data Excel will default to count. I want to zoom in on this table. All right. Notice how if I step in or out of my pivot table, the pivot table fields go away. Notice how if I step in and out of my pivot table, this ribbon menu is dynamic. No pink part, now the pink part, no pink part, now the pink part. That goes away. So here's a problem I often see when people are generating pivot tables is my menu thingy went away. Well, how do you get your field list back? One click into your pivot table, and then you can see you've got 2 menus up here. But when you're in the Analyze section, you can see field lists, plus or minus buttons, field headers. I can get rid of the field headers. I can get rid of some buttons. I can get rid of my field list. I want all those things on my table because I want to be able to see who worked the most days. It looks like Elvis is the workhorse. This is a useful table. I might want to take this table with me. I don't like count of day though. I would prefer to have a different name. In order to get the dialog box here, which says one name or another, all I have to do is double click on count of day, and now there's a bunch of different things that I can change here. I'm going to change, first of all, custom name to frequency. Now it says frequency. That's pretty cool. But right now it's just a table. Let's say I wanted to add, how about the day of the week? Now let's drag this into ether, it's gone. I drag it back. Now it says count of day. The interface for pivot tables is really a drag and drop. I can drag it in there, I can drag it away. Drag it away and it goes away. Now it's count of day, and I'd rather have it say frequency. So now I make it say frequency. I got a table, frequency, that's great. But that's not enough information for me. It looks like Elvis, well, he works most of the days. He's the mode. You know what? It would be more useful to me, actually, if I could find out what % of days that each of those guys worked. Once again, I can double click on this heading, and rather than having count, I've got this dialog box here. Show values as, change a calculation, % of grand total, Now I know that Elvis worked 46% of the days, Jasper 21, and Brutus just under 33. That's no longer frequency. I should change it to percent of days worked. And now I've got this table. So far, we can see that Excel is really useful in generating We can see that Excel is really useful in generating these summarization tables. In the case of just looking at what percent or what count of days particular people work, that's all well and good. That's a simple table, but I could have gotten there just using that count if function I showed at the very beginning of the video. Now we're going to start getting a little bit more complex. We're going to take a look at how to create contingency tables, sometimes known as crosstabs. Crosstabs is a frequency table that has 2 or more variables in it. In this case, I can cross 2 tables to generate a crosstab or cross table. So rather than having percent here, I actually really do want to go back to just no calculation, just a raw count. And since it's no longer percent of days worked, I'll change it to frequency. Side note, in Excel, there's so many different ways to do the same thing. Over here where it says frequency, notice that thing changes. I hit this drop down and I can go to value field settings, and it's that same dialog box. So I got frequency here, but I'm really concerned as well about if someone's working a lot of weekends or they're not working weekends. I'm going to drag this variable day, which is Sunday through Saturday, zoom out a little bit, so I can get a better understanding who's working on what particular days. It looks like of the 365 days, Jasper has only worked 8 Saturdays. What a jerk. But then again, he's only worked 78 days. It looks like he does work about the same amount of each type of day, works fewer Saturdays, works a couple more Sundays than the other days. It looks like Brutus tends to have Fridays off. It looks like Elvis tends to have Sundays and Mondays off, but does a lot of the legwork for Tuesday through Saturday. So this crosstab allows us to get a better understanding of one or more variables and how they play together. What if you don't want the days of the week across represented by each of the columns? Well, drag employee to day, or to columns, drag day down to rows, and now we have effectively the same table, but we've just flipped its axes. Now we have the days of the week listed here for each row, and we have the employees listed for each column. Same numbers, different presentation. You know what? What if I don't care about the weekends and I only want to show Monday through Friday? That's what these triangles in the boxes do. I can click on that and I've got filter boxes and I can uncheck Sunday and Saturday. Now I've got the same table, 261 days, because that's how many days there were in this year if we include the weekends. And it looks like Jasper works as even as it can be. It looks like Brutus works a disproportionate number of Mondays, and Elvis doesn't work as much at the beginning of the week as he does towards the end of the week. But this is not a 5-day operation, my pretzel factory. It's a 7-day operation, so let's include all 7. Important to remember that if you do filter things here, that you do put them back after you get rid of them. Right now, this is just crosstabs. Crosstabs are discrete. They are counting. Remember when we looked at this data, we said we're ultimately counting the number of days for these days. I want to get rid of these 2, though. Come back to thinking about our data. We've generated contingency tables and crosstabs, but the thing that we haven't done yet was the summarization stuff like we did down here. Not all of these are available in pivot tables, but a lot of them are, and they're available quite readily. So let's still keep an eye on our 3 employees, Brutus, Elvis, and Jasper. But you know what? As much as Brutus should be on the top, since Elvis does work more days than the other two, let's move him to the top of this list. This list, which I want to call employee. I could just edit that box. Elvis should be at the top. I right-click on Elvis, and now I have the choice to move him up or down. I move Elvis up. Now it says Elvis, Brutus, Jasper, and is not in a somehow arbitrary alphabetical order. Let's look at the actual sales and stuff. So let's take units here. I want to put, the total number of units. I want to know the total sales. You know what? I don't want sales. Let's just do all units. Drag these down in here. Now I got a scroll bar because I've got so many things. This is pretty wide. Click out of it. I click out of my pivot table and the fields go away. And now I can look at the summarization here. And I can get a grand total. Just under 730,000 traditional units were sold, 550,000 odd rods, 36,744 COTS nuts, 5,450 buns and noses. Notice how in the case of all of these, it says sum of. Well, I can change those names just as well. Maybe I want to do count. Well, count is just going to count the days. It doesn't count the number of pretzels. It counts the number of times there were units in each one of those. I could do an average. I'm just looking at this one right now, by the way. Not looking at any of the other ones. Oh, gosh, that's ugly. Undo. Control Z. Thank you. But now this tells me on average. So now I say Elvis, on average, sells 2,001 units, where Brutus, on average, sells 1,994, and Jasper, fewer still. So I can do average. In fact, you know what? Let's say I'm only considering traditional units. I want the average. Maybe I also want the total. So I drag traditional units down here, and I got sum. I want sum before average. Now I've got the sum. I've got the average. Maybe I also want standard deviation. So I can click down here, say value field settings. Standard deviation. If it says P, that's population. STDEV, 2Ds, gives me for the sample standard deviation. Now I've got sum, average, standard deviation. That's too many decimals. I don't need all them decimals. There we go, whole numbers. Now recognize that this is there's still a decimal hidden in there. It was just starting to look ugly, and I didn't like it. Speaking of ugly, I would rather have this just say S, because S is the symbol for standard deviation. Although it's probably good to know what the standard deviation is for. So I'm going to say it's the standard deviation of traditional, and then it's units, not money. Average, sum, and so on. So I could change these labels to suit me. I can change even more things. This right here says sigma values. Where else do I see sigma values? I'll let you think about it for a second. Thirsty. Sigma values is down here. Sigma values as a field within these areas allows me to orient the way my particular tables are set up. If I drag sigma values down here where it says rows, the shape of my table is going to change dramatically. But it changes in such a way that I now have in each of the rows the summarization. Before, each of my summaries is as a column. So I have the sums for each of them, the average for each of them, and the standard deviation for each of the employees in columns. But if I want everything in rows and nothing in columns, I now have this. This looks like a pretty nice summary. I have the sum, I have the average, and the standard deviation. But I have that same pattern for Elvis, for Brutus, and for Jasper. That's pretty cool. Let's go back. Oh, you know what? I'm going to drag month down into where it says columns. If you imagine what shape this is now going to take, I'm going to have 12 columns, one for each month. And within each of those months, I'm going to have the same summarization, sum, average, standard deviation for each month. You know what else I want here? I'm going to drag something down here that says employee, but I don't want that to be count of employee. I actually want that field to be just count or frequency. Now it's his frequency, so I know how many days. And in fact, I want the number of days on top. I'm just dragging and moving things around using these arrows to modify the fields as I need them. And now I have January, February, March, April, May. I know that in the month of January, Elvis worked 3 days, Brutus worked 11, Jasper worked 7. I know that Elvis had the most consistent month compared to the other two. The lowest standard deviation means the most consistency. Remember, a variance of 0 means no variety. No variety means a lot of consistency. A lot of inconsistency means a lot of variety. Variety and consistency are inversely related. The lower the standard deviation, the lower the variance, the higher the consistency. Brutus had the highest standard deviation, therefore he had the most variety. Some good days and some bad days, whereas Elvis tended to have more consistent days. I know how many days he worked. I know how many pretzels he sold. I know what his average January day looked like. I know what his standard deviation. And I have this for each month for each employee. I could continue to build these out for sales dollars, for the other types of pretzels. I could include, maybe I'm only concerned about day of the week. Uh-oh, this table's going to get unwieldy. Now I have only the Sundays for those months. And now Sunday total, and only the Mondays, and then Monday total. Wow, this is getting really big. It's no longer a summary. Hey, it looks like Brutus only worked 1 Sunday in April, so he doesn't have a standard deviation for that. There's no variety when you've only got one observation. This data set's getting out of hand, but let me back it up just a little bit. And so I can look at just January, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday in January. Those are familiar summarization numbers there, but I can say Elvis worked 1 Sunday, 1 Monday, 2 Tuesdays, 3 Wednesdays, and so on. Because he only had 1 Sunday and 1 Monday, he has no standard deviation. There was no variety. When you have only one observation, you can't have any variance. But this seems complicated. I wonder if there's a better way. I haven't even used this filters area here. So actually what I'm going to do, I'm going to drag the month up here to filters. And now I have what looks like Sunday, Monday, Tuesday, and 168 days that Elvis worked, and 119 for Brutus, and 78 for Jasper, for a total of 365 days. That all looks pretty familiar. But let's say I only wanted to look at January. I can filter out all the other months. Now I've got the 31 day January summary. Or I only want to look at June. 30 days has September, April, June has 30 days. What if I only want to look at summer months? June, July, August are summer, September, October, those are just dumber. That's another rhyme I learned. But there are 92 days in June, July, and August, which isn't actually summer. Summer's barely June and mostly September. But June, July, August. 92 days in those 3 months. Remember, if you filter something out, you should probably filter them back in. And always take a look at the checksum. That's a frequency that's really useful there, 365 days. Wow, you can do a lot with pivot tables. You can generate contingency tables and crosstabs and all of these fantastic summaries. I don't even have to look at any of these other things over here. There's so many things there, so many tables. My gosh, it seems like what could make this possibly any better? Well, pivot charts make this better, make it so much better. There's so much trash in here. I want to get rid of a lot of this stuff. So I'm just going to start dragging things out. I didn't actually have to drag anything out. If I wanted to, I could actually come back up here to my original data set and say, you know what, insert a new pivot table. And now I have my original pivot table, which I've since destroyed, and a brand new one. You can have multiple pivot tables within the same workbook, multiple pivot tables which reference the same particular data set. But let's say I want to go back to, just strictly speaking, thinking about how many days particular employees worked. In this case, I've got employees as rows, and I want to do a count of the day. All right, and maybe I want to think about in the particular day of the week. So far, so good. But up here within the Dynamic Analyze ribbon tab, I see this little button for Pivot Chart. Pivot charts are so cool. Once I hit Pivot Chart, I end up with the same insert chart menu as I would get if I were in my data set and said insert recommended chart. But instead, when I insert a pivot chart, by the way, I can just insert pivot chart from the data the same way I generated the pivot table. Now I've got something that's even cooler. This pivot chart, notice it's a new one, it's sheet 3. This is my pivot chart. Has the same thing over here, it says pivot table, just like when I generated these new pivot tables. Pivot table. But now it says chart 1. To build a pivot chart, choose fields from the pivot chart in the field list. Again, I've got different areas here. It says filters, columns, rows, and values when I'm generating a pivot table. But I got filters, legend, axis, and values here. Maybe these things work the same way. So I'm going to take employee, drag it down to axis. I'm going to take day, drag it down to values. So now I have a bar chart that shows me how many days Brutus worked, how many days Elvis worked, and how many days Jasper worked. I can also include day of the week as an axis category, and I have this is Brutus, this is Elvis, and this is Jasper. And look at that, I've got Brutus's list and Elvis's list and Jasper's list. I wouldn't think to generate this type of bar chart for that summary. I might think of this type of chart. So now I have the 7 days a week for Brutus, 7 days of the week for Elvis, and the 7 days a week for Jasper. And this is the cool part about the pivot chart. I think one of the like 18,000 cool parts about pivot chart. I can change the pivot chart, and I also get a corresponding table which would generate this particular chart. That doesn't look like the same chart. You know why? Because I have, again, flipped the axes. Before, if I have Brutus, Elvis, Jasper as each of my rows, I have Brutus, Elvis, Jasper as my axis. On the other hand, I could have Sunday, Monday, Tuesday, Wednesday. And as we see here, even though Brutus and Elvis work a different number of days, Brutus and Elvis works a few more days than Brutus does, they both work the same number of Mondays. These big orange spikes all indicate Elvis, but that's because Elvis works more days in total than Brutus and Jasper do as well. Maybe I only want to concern myself with Monday through Friday. I can use the same filters, but this time they're actually in the chart. I can change elements of this chart. Let's bring our days back because we care about all the days of the week. You know what? I changed my mind. I don't want a bar chart. What I actually want here is, right click on here, change series chart type. I can have a pie chart. Now, that big orange chunk right there, that shows me 168 out of 365 or something that's nearly 50%, and I can see it visually. And I can now change the colors of this if I want to. Well, you know what? How about a gray color for Jasper? Oh, no, now it's changing all of them. Let's just make sure we're only looking at this one. I don't even know who this one is, but I'm going to fill it to yellow. And it looks like, yellow must mean Brutus. And I can do all this cool stuff to this chart. I can bring my pie pieces back in. Let's change that one. You know what? Let's just undo a whole bunch. Control Z. Let's get it back to default. I can generate lots of different summaries here. I'm not going to get as complex as I did before, but trust me when I say that you can do all sorts of different things to this. There's another recommendation I have. If you want to generate a number of different charts here, let's say you want to filter out and you want to do only by employee, let's say just Brutus, and I want to know this is what Brutus's week looks like, and then sometimes I want to look at Elvis's week, and sometimes I want to look at Jasper's week. I can see all of their different pie charts. If I want to, I can copy this whole pivot chart. By the way, hold control and drag the tab, and you can copy it. And then if I want to, I can copy that, paste as values, and now there's no more formatting in this table. I can change any of these pivot charts all I want. Just get rid of Mondays, because who likes Mondays? No, it's like Trivial Pursuit. This one has not and will not change. I can verify that by right-clicking on it, right-clicking on the pie, selecting data, and now seeing that in here, the axis labels are not dynamic. They're actually those words in quotes. If I edit the series, I see the values are 13, 12, 11, and so on. If they were dynamic, they would say something like this. Pivot chart 3, which is our sheet number, along with the location of the array, B4 to B10. But I don't want that. Escape, get out of here. I just want these raw values. This chart will not change unless I change the raw values. These chart numbers, these values, aren't even associated with this table. I can change this table all I want, and this is still solid. So I can generate pivot charts. One last element of generating the pivot charts, and this is something I like to show as often as I can, is generating a histogram, because histograms are really useful. So let me go back to, generating a new one. Now I just got a whole mess of these things. Hold control and drag this. And this is a pivot chart to demonstrate a histogram. Usually don't generate them this way. Usually generate them some other way, but let's see how this works. I can't get rid of the pivot chart, but what I can get rid of is all that stuff. Now, a histogram is a count. It's I won't go into too much detail what a histogram is, but just to show you how to generate it. If I want to know the histogram of units, I don't want a pie chart. A histogram looks more like a column chart. And I want to have units down here, but I also want to have it in the axis categories. Now, right now, it's doing a couple of different things that I don't like it to do. First of all, it should include everybody so that I have 365 days. But a histogram will show you a count, the sum of the heights of the bars of the histogram. The heights of the bars are frequencies. Now, if I want to change those to frequencies, I come in here and say count. Change it to frequencies. This goes back to that original question about the mode. In this case, the total frequency is 365 because there are 365 days. On 2 days, I sold 1,805 traditional units. Now, this should go ahead and say traditional units sold. 1 day, 1688. 1 day, 1775. And this is the chart that corresponds with that. Now, that looks kind of funny. It looks like 5 days I sold 1,947 traditionals. On 5 days I sold 1,982. There's a number of different possibilities in here. But in order to make this a histogram, I need to be able to group together with a certain interval size ranges that I think are appropriate for interpretation. Right-click on here where it's in the traditional units sold rather than frequency and tell it to group. You right-click over here where it says anything like here. You say group. I just repeated that. It was unnecessary. Really only do it once. Group. Starting at, ending at, and how big you want your intervals to be. My recommendation, since that's the minimum and that's the maximum, why not put this closer to numbers that we're familiar with? For example, I will do 1,600, which is below the minimum, and 2,300, which is above the maximum, grouped by 100, and now I have 1,600 to 1,699, 1,700 to 1,799. Again, that gets around the idea that 1,909 and 1,910 are basically the same thing. To complete it as a histogram, I want to change the gap width to 0% because those things should all be touching. And my gosh, there's a lot of these windows over here. But this is a histogram, which kind of looks like a bell shape, which kind of looks like a normal distribution. I can add a little bit more discrimination. I can increase my interval size. Decrease my interval size, which increases the number of intervals. Maybe I want 30. Looks like it may be modal here in the middle. I think that's unnecessary discrimination, so it looks like it's kind of bimodal-ish. But I think that following the 2 to the k rule, we should probably be looking at something more like 100. Because those are ranges which provide us the more realistic, between 200 and 300. And then we could do some of the standard, make this thing look better. We don't need those. I don't know, maybe we want to put some stuff at the top, add some data labels so we can actually see the counts. Who needs that? That's unnecessary. And we should probably call this traditional pretzels, sizzled. And now it looks like you're hit the new. Maybe we want to rotate those a little bit. Tick marks, labels, number, all sorts of things over here that we could do. We could edit the way they are. The labels, oh my gosh, there's so many things. Do I want it next to the axis? Do I want it above the axis? Do I want it low? You know, at this point, let's see, where's the thing? Give me that, yeah. Whatever the case, I've modified the crud out of it. I could even say that one's the mode, so let me just change that one to green. And so on. Actually, these probably go together. So the mode is somewhere in here. Oh, now they're all green. Let's bring this back to closing thoughts. Closing thoughts. The first time you encounter data, you should go ham with this guy. Because whether or not you follow this precisely, you should at least be able to come up with some of the basic descriptive statistics of the fields or variables within your data set. Using something like pivot tables helps you generate summaries within particular buckets or subgroups or samples. Using pivot tables also allows you to generate histograms. Now, the last way I generated that histogram using the pivot chart, you can still generate a histogram the same way. The point is to remember you want to, for whatever the count, the frequency of things that you want to generate, that needs to be the under the rows or the axis categories, and make sure you're counting within the sigma values area. Those two things will help make sure that you generate a solid histogram or a histogram at all. There's a number of different other things on here. We can talk about different types of charts. Really just talked about bar charts, pie charts, and histograms there. Pivot charts, you can get some pretty basic line charts out of there. It's pretty hard to get a cumulative frequency distribution out of that, but that does require a bit more calculation in order to get what you need for a cumulative chart. Anyway, in conclusion, this is useful. Pivot charts are useful. Pivot tables are useful. And I hope this has been useful. Cool. Bye.